We're going to consider systematic and random errors. We're still under the main topic, general physics. So, in experiments or in measurements, in everyday measurements, we encounter two types of errors, which are systematic and random errors. When making measurements, in carrying out experiments in physics. So, so our main topic for today is systematic and random errors. That is the main topic for this lesson. Right. So I'm going to start with systematic errors. A systematic error is defined as an error. It is defined as an error due to a faulty measurement instrument. That is basically the definition for a systematic error. Systematic error is defined as an error due to a faulty measurement instrument. Examples of systematic errors. Want to consider, it is very important that we consider examples of systematic errors. Examples of systematic errors. Examples of systematic errors. 1. Zero error. A zero error is a very good example of a systematic error. Wrongly calibrated measurement instrument. Wrongly calibrated measurement instrument. Also, let's also consider the causes of a systematic error. Right. Examples of a systematic error: zero error is a good example, or a wrongly calibrated measurement instrument is an example of a systematic error. The wrong calibration measurement instrument. Or also causes of systematic errors. Causes of systematic errors. I'm going to wrongly calibrated instrument again. Wrongly calibrated measurement instrument is a cause of a systematic error. Again, zero error in an instrument. That zero error in an instrument. Again, is a cause of a systematic error. How a systematic error is dealt with. So I'm going to deal with subheading how a systematic error is dealt with. How a systematic error is dealt with. A systematic error can be eliminated. A systematic error can be eliminated. So it can be eliminated by changing the instrument. You can change the instrument, use a correctly calibrated instrument. Changing the measurement instrument, or eliminating the zero error. Eliminating the zero error. So you can eliminate the zero error in an instrument. You can eliminate the zero error. Effect of a systematic error on measurements. So I want to consider the effects of a systematic error on measurements. It's very important that we consider the effects of a systematic error on measurement. Effect of systematic error on measurements. A systematic error shifts measurements away from their true value. Shift measurements away from their true value by a similar amount of fraction. By a similar amount of fraction and in one direction. That is the effect of systematic error on measurements. The systematic error shifts measurements away from their true value by a similar amount of fraction and in one direction. For instance, let's consider a graph where we've plotted A against B. Let's consider the following. Suppose we've got variables A and B. If there was no zero error, we would have a graph like this, which passes through the true origin. This is a true origin. Then, suppose there was a zero error. This is a zero error in an instrument, or also zero error. Right. So if there was a zero error, maybe the zero error could be negative. This graph, so here there's no zero error. So this graph and that graph, they are parallel. So all the measurements have been shifted by an equal amount in one direction. Perhaps here there's a positive zero error. All the measurements have been shifted in one direction by an equal amount. So these are the effects of a systematic error. It shifts measurements away from the true value by an equal amount, by a similar amount of fraction in one direction. So if there's no zero error, the graph passes through the origin. But if there's a negative zero error, these graphs are parallel. So there's a zero error, negative zero error, all the measurements have been affected by an equal amount. There's a positive zero error, all the measurements have been affected by an equal amount. Now we're moving on to random errors. Random errors. This is an error in which the measurements are evenly scattered about a true value. An error in which the measurements are evenly scattered about a true value. That is how basically we can define random error, because it causes measurements to be evenly scattered about a true value. Causes of random error. Let's consider causes. Random error can be due to variations in environmental conditions. Variations in environmental conditions. Also, lack of enough experimental skills by the observer. So such can be causes. Each examples of random errors. Examples of random error, or example of random error. Parallax error. Parallax error can result in random errors. How a random error is dealt with. And it is very important for us to consider how a random error is dealt with. How a random error is dealt. A random error cannot be eliminated, rather it is minimized. It can never be eliminated. It is reduced. Or minimized. So you cannot eliminate the random error. So it is reduced by taking many measurements. It is reduced by taking many measurements and averaging them. That is how a random error is minimized. Now, effects of random error on measurements. So it is important that we also consider the effects of random error on measurements. Effects of random error on measurements. Effects of random error on measure. It causes measurements to be evenly scattered about a true value. So measurements they are scattered by both positive and negative magnitude. Are scattered, or we can say are shifted in both negative and positive directions. For instance, let's consider the line of best fit. Suppose there is a graph, we plotted A against B. This is the true origin. So this is the line of best fit. So these are points. So the line of best fit is scattered about, the points are usually scattered about the line of best fit. So the measurements have been shifted in both negative and positive directions. Right? The line of best fit. So the even scatter of points about the line of best fit is an indication of a random error. So in our next video, we want to consider precision and accuracy. And also we need to consider the errors associated with precision and errors associated with the accuracy.